we can use a caption which is displayed on the on your on your screen when the input is required or when this command is executed. So there are a few examples here, and there's one more thing that you can do while taking the input. You can also type convert your input, because by default every input you use without converting it, it is treated or it is taken as a string value. And if you want to convert that into integer, you can use int function or typecast int, or if you want to convert it to float, you can convert it to float or typecast it to float data type. Okay. And for the Python output, we know that we use print statement, okay, and we can use the captions, single string, or if we have multiple values, they can be separated by using the comma, such as in this case. So the value of A is A. So A is 10, so it prints the value of A is 10, okay? Or in this case, the value of C, which is A minus B, which is 7 in that case. Okay, so whatever is in double quotations or single quotations, that is printed as is because it is treated as a string literal, and the other variables they or expressions, they are evaluated to a single value, and then single value is printed on the screen. Okay, so here is the generic, basically, print function. So print function, we have got objects that could be any variables or strings. Then we can specify the separator between those objects. Okay, we'll be exploring all of these in detail in this lecture, in the coming slides. And end is basically that how you want to end your print statement. By default, end is \n. It means that every time you execute a print statement and the next print statement prints on the new a new line, default behavior. But this can be changed using this keyword end of your line. And I think that we did a little bit about this in the lab, and we will be practicing with this in the coming lab as well. And there are two more parameters which we are not going to cover here, but in, say, lecture 5, we will be covering. So that is file and flush parameters. That is when we want to write to the files or any documents on our hard drives. But right now we are concerned only when we want to print on the screen. Okay. So, and then there is a format specifier. Let me show you about these separator and end. So as I mentioned, that separator is that parameter which you want to use as a separator between your objects. Okay, so these are main objects, 1 comma 2 comma 3. This is the they can be replaced, or they could be text or anything which is separated by commas. And separator specifies that what specifically you want to add as a separator between these objects or values. So in this case, they were simple integers, and we have used a hash as a separator. So you see, 1, 2, 3, 4, they are all separated by hash. And in the last line, we have got a separator as well as an end uh, a parameter. So we do separate our objects with stars, but uh, we end our print statement with an ampersand sign. Okay. The default, as I said, that if you do not mention anything regarding end, that the default behavior is that it is a new line. So every time your print statement is ended with a new line, it means that the next statement. But in this case, if I ask you that a new print statement is executed, where will it start printing?
Is it on the same line?
It's on the same line because we have ended this statement, ended the printf statement using this ampersand sign. It won't be going to the next line. Or you can use, if you just do not want to show anything and you want a continuation in the printf statements, what do? You just remove this and, or you use just a simple null space. It means that a single quotation opened and closed, or a double quotation open and close. I mean, you just do not want any end operator. Okay, and that could be the case with the separator as well. If you just do not want any separators. Okay, and the default separator is one space as well. Okay, and I hope that clarifies the end. There was a question.
Yep. Let's say, can I like, next to the and, for example, also like, state slash and?
Pardon? State.
Can I make to and, like, let's say it will be ended, for example, by a symbol, and after that can I place like slash and for new line?
Yeah, yeah. The fresh start will be from the. But then, if you want, then you can use. You can use the next print statement can also be started with a new line as well. That is that we'll learn in the lab. Just remind me, and I'll show you this.
Yeah, thank you.
Okay. So what is the question? So the next thing printed would be on the same line. Yes. Because we want to format, this is for the formatting of our, specifically task 2 and assessment 2, you would need these separators as well as even if you do not use separators, but at least you would be using end command in that case. Okay, so if you just do not want to uh, print every successive print statement on a separate line, then you can use the end operator with that. Okay, so we can specify the format specifier like so. Here you see that we have got a string, and in that string we have introduced some curly brackets. And now this is the case where we do not want, or we do not know that how our strings would look like in advanced. Okay, but for now you have seen that we type in and then we have a fixed string. But some cases we would not have any fixed strings available, and we would say that we want to change our string value later when the inputs are available. So what do? We use dot format uh, operator. Okay. And in that case, these curly brackets are replaced by these parameters or arguments of this format specifier. So when you print this command, so the first curly bracket set is removed with the value of x, which is 4, and the second one is replaced with y. Okay. And you can also mention the sequence in which you want to specify. So in this case, if you say banana has got the uh, zeroth place in the format specifier, and the apple has got the one place. So they start from 0, 1, 2, and 3. So you want to print or say construct a text or a string. I like banana and apple. So you say 0 and 1. So zeroth element would be replaced with this curly brackets, and the first or value 1 curly brackets, that would be replaced with apple. And you can change the sequence, because this list could be a longer list, and the way you want to construct, you can construct. So now in this case, apple would be placed first and banana later, because you have chosen to like so. Okay, so what if sep is and end is keep outputting a syntax error? So if they keep
Sorry, just to interrupt you.
giving you the syntax error, we need to remove the syntax error, or we need to fix that error. Yes, question?
Yeah, so is that like an array?
Yeah, we can think of an array or list, but not particularly. This is just their sequence.
So for
But
example,
you're right. They are like so because these are their indices. So this is index 0, banana is on index 0, and apple is on index 1. You're right.
so if you had like 10 like items and you just put 0 and 1, it'll just display the first and the second. Yeah.
Yeah.
Okay, thanks.
Can I
Yes,
use
yes, of
this
course. You
format?
can. That's what
Can
I'm
I-
explaining. It's not only 2 items. You can have more items in that.
Can I use this format to format this one and put it in the chat?
Post between second.
Yes, the print uh, open bracket F.
No, F string you cannot use because we haven't explored this. We will be exploring later. These are F
right.
strings. Yes. Usually, when you use generative AI, this gives you such formattings, and that they are not allowed at this stage because we
Alright.
want to learn you to print manually at this stage. Okay.
Okay.
Yeah. Okay, moving forward, these are few. I'll give you this slide. So go through this, and there are few more input and output commands. Now we have pretty much covered everything. These are from the previous because it was from the previous uh, week. We discussed input and output. Now coming to the actual topics for this week. We have got the comparison and Boolean logic. In this part of the lecture, first part, there are going to be 4 parts. In the first part, we are going to discuss Booleans, variables, and logic, and then comparison operators and logical operators. Okay. So we start with Booleans, though we have some introduction about Booleans. Uh, from the discussion here and there, but we want to see in the details. So far we have seen 3 main different data types, if I ask you, and they are what? They are integers, they are float, and they are what? They are strings. But there is a fourth primitive or basic data type in Python that is called Boolean. And Boolean represents the condition or the situation where our values could be any of 2 options, say on off, right, true false, negative positive. In such cases where there is no third possibility, we want to use what? A Boolean data type. Okay. So, for example, you could say that your music is paused, or your video is paused. You're developing a software, a multimedia player. Then you want to use a button where you want to save the status of that. If we do not have access to our uh, Boolean variables, which we are going to see, conventionally, what we can do is we can store these values as strings or integers. Yes, no, as a string, or is paused. We can say is paused 1 if it is true, or if it is 0, it is not paused. Okay, but we have very specific data type available. We would see, and there are different options. So to program those, or to cater for these, so we use Boolean. So these are the conditions where Boolean can be a data type, where we see that this is these are the situations where you want to have a data type where only one of 2 possibilities are there. So these buttons, either they could be on off, or you say that these radio buttons, they can be, or these options can be yes or no, or you have a button where you say unmute or mute, or we have different options, and you say that we can select or unselect. There is only one option for each of these texts or options, or there is one possibility, or check uncheck. So in these cases, we have got a Boolean data type. Okay. And Boolean literals are what, like in numeric literals, we have 1, 2, 3, 4, or in text, we have all the possibility we can type anything. But in the case of Boolean, we have two different possible values, either true or false. So these are the literals. And you can use these values, true or false literals, to store to your Boolean variables. Okay. And you can convert uh, other values, other numbers or strings to these values. So a value that converts to a true value is called to be a true truthy. Okay, and a value that converts to a false is falsy value. Okay. So far, any questions or any confusions? Okay, no questions. So
No, sorry. Could you give an example of how you convert to a truthy? How could you convert an integer?
that's what we are going to do now. See?
Okay, thanks.
So you see, a Boolean 0 is false. Okay, you see, Boolean 0 is false, and Boolean minus 42 is false. Here it is true. From numeric types, if we say that Boolean 0, uh, Boolean 1 is what it should be. It is not. I think it's Boolean 1 should be going to be true. There is a mistake. If there is a question if case sensitive. No, it's not the case sensitive.
Hello, sir.
Yeah.
Quick question. It's regarding the initial content that we just discussed about the signature of the print statement and extensions of print statement. This content I cannot find in the LMS. I'm just wondering where should we get this one, because
You would get this, good question. You would get this as a part of this PPT. I've added this content because there could be questions regarding the assessment and all that. So
Exactly,
when
yeah.
I upload this PPT, then you would be able to access that. Okay.
Perfect. Thank you. Thank you.
Yeah. All right. So yeah. So all the let me open my. So as it says that for numeric values, a 0 is false value. Everything else is true. So a perfect 0 is false, and everything else is true. So minus 42 is what is true. 0.00 is again a perfect 0. There is no chance that there could be a positive or negative value associated with that. That is false. Okay, and then a Boolean value 0.0001, because it has got a very small value associated. It is non-zero value. That's why it is true. So this is how numeric values are converted to Boolean values. Okay. And for strings, that we have an empty string that is false, and everything else, if it is not empty, even including the spaces, they are all true values. Okay, so only false is when we have an empty string. We do not have anything in that, so uh, that is your false. So the question is the string no truthy or falsy? What do we say? Truthy, because it is not, we go back, only false is when you have an empty string, because it is not empty string, it is true. Okay, so question from a student: when I run the following code, x equal Boolean input print x, Okay, when I input 0 or 0.00, that the code prints true, while just pressing the enter key returns print false. Why is it so? So what is our answer or explanation for that? Anyone?
That an empty string.
Mhm.
If you just hit return, X will have an empty string. Is that right?
Yeah, but when I input 0 or 0.0, the code prints true.
Oh, right.
Because the Boolean function has something in it, so it's true.
Yeah, Boolean is converted into true uh, because it might have some value. Let me check there.
So that may be not a number thing. It is a string.
Yes. So we are converting
It's a
a
string.
string
Yeah.
to what? A Boolean. Okay.
Mm.
So we are not converting an actual number to Boolean. It would have been a different case when we place an int here before converting it to Boolean, then it would be a different case, isn't it? Do you understand that what I'm saying here? If it was bool int input, okay.
Yes,
So,
there's a one question is the X is capital X equals bool, and the
yeah,
print.
that is a typo. That is a typo. So it doesn't matter. Yeah.
Sorry.
Yeah.
I got it. I got
yeah,
it. Thank
yeah.
you.
So no, that is automatically a unless if you put an int at the front, it will be automatically a text, and therefore
Yeah, because
it's not
you're right.
recognized as number.
The default behavior of input is because it is text.
Yeah.
So 0 or 0.00, they are entered as text and then converted into Boolean type.
Yeah.
Because text is what is not empty. That's why they would be giving you true value.
Yeah.
Okay. Yeah. And when only enter is pressed, it means the text was an empty string, nothing was entered, then it was true. Okay. And I'm glad that we are following. What is the value in having Boolean values turned to binary true and false? There is no specific binary values in binary data type in Python. So in case of binary or in binary in place of binary we have Boolean. That okay, binary 1 is true or binary 0 is false. We can associate like so. Okay, now coming to the comparison operators. Uh, from the previous discussions and even from the little experience with the lab, you know that we can evaluate some mathematical expressions into certain fixed numbers. So 2 plus 2 would be going to 2, or even we did some string concatenation. We call that string expressions. So similarly, we can have Boolean expressions where a combination of Boolean values that evaluates to a single true or false, or a single Boolean value. Okay, let's see some examples here. We say we can compare two Boolean variables, and we can use uh, we can use different operators. So equal operators, if x, the value of x, Boolean value of x is equal to y, then it would return, though this is true and this is true, if these two are true values, two Boolean values, then it'll be giving us what? It'll be giving us a true value. Okay. And if they are not equal, the two Boolean parameters or two Boolean values, they are not equal, then it'll be returning what? False. Or if we can say if they are not equal, and they are not equal, then it should be what? If we say that X is true and Y is false, what should be the result of this?
True.
True, because this expression as a whole is true. And when X is greater than Y, and the values which depends, so values of X, they can be any values. Say 5 is greater than 3. What does it return to us? What is the evaluation of this? 5 is greater than 3, then it is true. If 3, we try evaluating 3 is greater than 5, then it is false. Okay. So similarly, we have got other operators less than and greater than equal and less than equal as well. Okay. So here are some examples. So
Can you combine these with and or?
yeah, when we discuss and or, we'll see, of course. Now, a string comparison. So a string comparison are based on this very specific term, which is called lexicographical ordering. Okay. And that ordering is lexicographical ordering is the ordering present in our dictionary, where apple comes before banana. Okay. Because A is appearing first in the order, then banana in the dictionary. So when we try comparing, so word, let me show you. So we have a word apple, and we say word apple greater than banana, it is false, because apple comes earlier in the dictionary, because apple is when we say apple, is it equal to apple? Word is equal to apple, it says true. Word is whether word is less than apple pie, and it is true. Because why? Can we explain this, why this is true?
Is word the operator in this case?
Yeah, because in this case, the pie, if it appears in the dictionary, it would be after apple pie, because as we expand our words, okay, the or number of letters in any word, they are after that. So app, for example, if we say APP, would be before apple in the dictionary. That's why apple pie is later, or apple is before apple pie. That's why it is true. But now, why is this case that word zucchini is, though Z is the last letter, but it is false in that case?
Is this uppercase?
It is uppercase, because all the upper cases, they appear before the small cases or lower cases. Okay.
It takes precedence, yeah.
Yeah.
Okay.
So precedence, basically lexicographical ordering that follows in that case.
So can you give us an example when this might be used? Like if some like in a like.
Yeah, then for instance, you want to compare passwords, then for instance, this could be used, right?
You want
So
to
if there
compare.
was numbers inside of the string value, would they come first?
If they are that depends. If they are added later in the order or before that. You understand that if it is apple and apple 1, 2, 3, so apple is of course in the earlier order.
Mm-hmm.
Yeah.
Okay. But if it was 1, 2, 3, Apple, Apple would still come first.
Yeah.
Okay. Thank you.
Yeah. And sometimes even because I understand this, and you need to understand, might not be knowing the exact answer because I haven't explored the whole, I would say, workspace. But we now understand the method or the or the state how that is working behind. So we can go and try finding the answer for exact precise combinations using our Colab and our Python programs. Okay, moving forward. So when we are comparing, so sometimes some values we would be able to compare, but sometimes they can give us some errors. For instance, we are comparing an integer with a string value. That is compared and it returns because it is not equal to this, that is returning false. But here we have tried comparing 0 using the less than operator, and it is going to give us some error. So it's when we are making comparison, so we need to be careful that what values or what data types we are going to compare and for what purposes. So this is one thing to keep in mind. So okay. What is the Python Boolean expression for twice the value of x is not equal to 100? So we can just look at the answer. Okay, so twice the value of x is not equal to 100. All right. So there could be different writing styles, I'd say. That's the same thing. Now coming to the logical operators. Logical operators, as we know that they can be used to combine Boolean expressions. Okay, when we say combine means that the results of different expressions, they can be combined using and, or, and not operators. And or are binary operators. We need to keep in mind, and the not is a unary operator. Binary means that they would be needing two operands. I will explore more here. So you see that AND operator or logical AND would be true only when the operands are both true. Otherwise, it'll be false. So when we say it is a condition, where two conditions are there, and when both two conditions are met, then the whole condition becomes true. For instance, I say that if the temperature is less than 30 degrees and it is not raining, then I'll go for a walk. So it means that both conditions should be true, then I'll be going for a walk. Okay, but if any of these conditions, if either the temperature is not less than 30 degrees, but it is not raining, then I'll be still not going for a walk. But if it is raining, but the temperature is less than 25 degrees, still I'll not be going for a walk. Or finally, if it is raining and temperature is not less than 30 degrees, I'll not be going for a walk. So for going for a walk, two conditions must be met. So here we say that we are comparing these two expressions. The first evaluates to what? True in that case, because x is less than y and x equals 5, that is also true. So true and true, they become true. And in this case, because y is not equal to 5, this part becomes false, and this is true. So false and true is false. And again, these both conditions are false. That's why it is false. And yeah,
we went to, I'm thinking ahead of time, but say for the test or exam, whatever you want to call it, we went to remember all these different tables, you know, true, 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 and all that sort of thing, or like, I'm just wondering what level our memory is meant to be at.
it's not very hard, and this is this is something you must know, because this is the part of your logic understanding. So this is the basic thing.
Okay.
The way you remember that what a plus sign does, you should be remembering that what AND operator does.
Mm-hmm.
Yeah.
Okay. Thanks.
And it's not that hard. For AND operator, you have to understand, or you have to remember that when it is true. For AND operator, it is true, true, true. Otherwise, false. If both sides are not true, it is false. For AND operator, it is only false when both conditions are false.
Mm-hmm.
Yeah.
Okay. Thanks.
Yeah. Or the way I have just given you an example, and condition like I'll be going for a walk when the temperature is less than 30 degrees and it is not raining. So you can keep something in similar in your mind, and you can recall that, and you'll be able
So is
to.
this like a if then else? Like
It's not if then else, we are just combining. But based on these, we will be performing in the very same lecture later. We will be doing if else conditions. They would be evaluating, if basically evaluates that if the whole expression is true, then it does something. It means including and or not, whatever we are using. If the overall condition, this whole thing becomes true, then if is executed, otherwise if is not executed. We'll see later in few minutes. Okay. And the next one is the not operator, where it just changes the value of any truthy value. So if it is true, not operator makes it false. And if it is false, not operator makes it true. Okay, and it's very simple. Now, combining Boolean expressions, so logical operators can be used to build complex Boolean expressions. So here you see there is one example: x is greater than 10 and x mod 2 equals 0. It means that x is greater than 10 and x is an even number, or y is less than 10. Then if either this whole thing becomes true or this becomes true, then do something, or this this whole thing evaluates to true. Okay, because parentheses, they are doing what? They are now here enforcing basically the precedence. Okay, we are combining and with this, because this is not part of that. So and becomes with this, and or is with that.
In no way is if they're both true, it's exactly the same as just one being true in this case.
In this case, because this or is deciding, or would be evaluated later, because this needs to be evaluated first. Okay, so either this or that, right hand side or left hand side of or operator would be deciding. If any of these would be true, if y is true, then y is less than, y is negative number, then it can be whole expression can be true, right?
Okay.
Yeah. Now here is extended precedence. You see, we have seen this in the previous lecture as well. So we have got parentheses, and then exponentiation, and then arithmetic multiplication and division, then addition, then comparison, then logical NOT and OR operator. That percent sign is not in the table. Here we see it is there. Okay, so what does the following expression evaluates to? So according to the table, let's see what when we expand this, a true. Now, how does it evaluate to a true? So when we evaluate to, so step one, the first thing we want to check is on the highest priority is what? It is, there are no parentheses, so there are no exponents. So we start with the multiplication. So the multiplication becomes 14 is greater than 5 and not 27 greater than 8. So the next step is that what do? We see what are the operators that we need to evaluate. So this becomes true because higher in the priority, 14 is greater than 5, that is true, and remains there, not remains there, 27 and 8. The next step, this becomes false because 27 is not less than 8, it is greater than 8, that's why this becomes false. True and not false. Now, next is that we make this not, because not is in any order, not is evaluated first as compared with and or. So this not false becomes true. True and true, they become true. All right, so in this part of the lecture, we discovered about Boolean data type, and then we saw the comparison operators: equal, greater than equal, less than, not equal. And also we explored the function and the operation of logical operators, and or and not. Okay, so that was all about this. Now, conditional execution. Before that, a short break for questions. Any questions so far? I think pretty much everything is clear. Hey, would format input to F would be allowed in the final assessment? Format input to F. Yes, you can use it, but simply, we are all listening here. You can use, rather than any specific formatting, you can use round function. Go and explore that. It rounds to a specific number of digits. Okay. So if you want to round it something to 4 digits or 3 digits, use the round function and compare it with the template output and just use simple print statements. You won't need any specific formatting for that purposes. Just use the round function. Okay, now I have resolved this issue for all. Use round function, no other format specifiers should be required. Okay, now conditional execution. So we, under this topic, we would be covering control flow selection statements and conditional execution. Yes, that's what I am saying. That once I was, that's something. What I'm saying is of course is allowed. Yes, I'll update it in the assessment task as well, so that you know that round function is allowed. Yeah, math library, sign function, they are allowed because they are all part of our expressions, and we have pretty much covered all the expressions in lecture 1 and lecture 2 as well. So that's all the expressions. So all good. Okay, now under the conditional execution, we'll see what control flows are, selection statements, and conditional execution pitfalls. Here we basically discuss if and else if structures. Okay, control flow. Control flow is that how we can control the flow of our program. So usually our program flows from top to bottom, statement by statement. We start from the top, and all statements are executed in a single sequence. But sometimes we want to make decisions based on certain conditions. So if the condition is true, the statements are executed, and if the condition is not true, a different set of statements is executed, or sometimes even nothing is executed, but a different path of the program is chosen. So that is called the control flow, okay, or control path or control flow, and that is done based on some conditions or decisions within our program. So here we see a simple program. So we start at age 78, okay? And if age is less than 12, we say display child, and then the program comes here, and if it checks again and age is greater than 65, display senior, and then display done. Okay, so you see, the flow of the program would be different based on the value of age in this case. It is not as simple that we'll be printing the same thing every time you run the program. It'll be really changing the path and making some decision. Okay. It's fine. No worries. It's all right. So if you have already submitted. But if you are confused or if you want some clarification, you can always, but not big deal. So formatting of up to a certain number of digits is not a big deal. So should not be any problem. Okay, so in this case, you see that our program executes. Now, I would recommend you, please, if you allow me to complete the lecture, and we have a complete 1 hour after this lecture for the assessment discussion. So uh, we can do that. I know that that is important as well, but uh, uh, if you allow me, please, to complete this first, because everyone wants to hear about the lecture as well. So we'll be taking all the questions for the assessment one by one for everyone after in the consultation session. Okay. And sorry for that. I'm not being rude, but we need to finish because this is, we have got more than 150 slides to cover tonight. Okay, so this is the path we need to follow. We follow in case of 78, but if it was just age is 10, then you would see that the different path is selected. So this is how control flow works, or this is the idea of the flow control in our programs. Okay, now check your understanding. What is the control flow for this program? We see that because it is this. Okay, so let's say x is 10 and it is greater than 8, and display happy. Okay, and display sad if it is not greater than. Okay. Okay. Now we have understood what the control flow is. Now we need to understand how Python does this, the control of or flow control in our program. So selection statements are used to define selection of control structures, and we use indentations for that. We will see. So let me show you. So if condition is basically used in controlling the flow structure. So basically this is the flow chart for that. If certain condition, if it is met, then go to the statement, otherwise go onward. So this is basic structure of our if condition. So if the condition is met, then execute the statement. And whenever we write if condition, the condition is between if keyword and the full colon. Whatever condition you want to write, that is the format, very specific format, and Python requires you to like that. And what condition you want to execute when the answer of the condition is yes, that should be properly placed, means that there should be proper indentation for that, even a single statement or set of statements, that if the whole block, if you want to run 10 more statements, they all should have proper indentation. Okay.
So what is the indentation? Is it just like you just want to do a tab?
You can press tab on the keyboard and it'll give you some proper indentation, or you can use a space, 2 spaces or four spaces. Usually standard is for 4 spaces. But if you have larger conditions or big programs, or quite a lot of text, you can squeeze to the 2 spaces for the indentation.
Hey,
Because
Noah, is indentation just for readability or is it part of the syntax?
readability, but it is important for Python as well. But it's not only the readability, because if you do not make it properly adjusted in the indentation, it won't execute. We will see in some examples.
So does that mean the minimum is 1 if you have space?
Yeah.
All right. Okay.
Yeah.
Cool. So you have to have something. Okay.
Yeah. Yeah.
Thanks.
Okay. Now let's see some proper examples. So here is some example. Okay. Num is 1, and we say here parentheses have been introduced, but that is not a requirement. You can write anything without these brackets or parentheses. So num is greater than 0. Yes, it is true. So it means that it is true, and then in that case this statement will be executed. Okay, and 1 is greater than 0. All right. And in the second example, we say that num is float, input, enter the number. If number is greater than 0, then you print the statement. So now if for all the numbers, if they are greater than 0, all the positive numbers, this print statement would be working. But if you happen to enter, say, -10, what would happen in that case?
It's not a float.
It's a float, or -10.0 you can enter. But in that case, because if would not evaluate this if condition, and num greater than 0 would not evaluate to true, so that print statement would not be executed. It would only be executed when this if becomes true, if condition becomes true, right? And we can use multiple if statements in our program. For instance, here you see x equals 8 has been initialized. So if x is less than 11, we see we write it is a smaller. And if we say that x is greater than 21, we want to print bigger, and then finally print finish. Sorry for this mistake. So at now, why should not we be using if statement? My question, whose question is this? Pradeep. Why should we not be using if statements in our assessment 1?
So this is week 2. Assessment 1 says week 1 concept should be used.
No, you should read that. It is week 1 and week 2.
And okay.
Yeah.
Okay. Week
It
one.
is a logical operator, yes.
Sure. Thank you.
Yeah.
So we can use everything that we've got in week 1 and 2, right?
Week 1 and 2, yes.
Yeah, yeah.
Okay, multiple if statements, a few more examples. Here we see that we want to grade, we want to place a grade, or we want to add a designated grade based on the marks. So we say that if grade is greater than 50 and grade is less than 60, print D. And same is the case for C, where grade is between 60 and 70, it's C. B is when grade or marks are between 70 and 80, including 70, because you see, one side is including 70 equal, the other side is less than 80. When you are 80 or above and less than 100 or including 100, we should have done that. This is, I think this is a logical mistake. If someone gets 100, then there could be a mistake here. So it should be including 100 as well. Okay. Any questions so far? I think that these are simple if statements. So
Is there any harm in having the print and if statement on the same line if it is only one line? The print on the same line as if, because it's only one line.
I'm glad that you have asked this question. Though it is not the convention, but we can have, if it is one line, you can use it. Yes.
Yeah.
Yes. For example, this is the very good case if it was because there was always one liner code after every if statement. Okay. But that adds to the readability if you just have the proper indentation and the execution commands. All right. So there is another program for even and odd numbers based on the mod function. So if the mod or the remainder is 0 when any number divided by 2, it is an even number. But if it is not 0 when you divide with anything, any number with 2, then it is odd. Okay. Yeah, they are part of this. I'm again repeating that they are these print statements and relevant information which we saw in the beginning, that will be available to you as a part of this this PPT. So I did this so that you have some knowledge about the print statement as you want to use it in your assessment as well. So you would have access to that via this PPT. If a statement was covered, but I don't think the others are explicitly covered. What does it mean by the explicitly covered? What is not covered, Tate? We will see. Still, we are math library. Yes. When I say when it is not explicitly covered, but it is explicitly specified, then of course you would be doing a little bit of your research to understand that how a specific thing works. Okay. That is the exclusion. If it was not there, then we could have complained that no, because there is a restriction and something is not specified, and you because I have specified apart from the whole restriction list, there is a specification for a specific sign function and math library, so you can use that. That is because to make that exclusion for that particular sign function. Okay, and don't worry, I have the other day the lab file was not opening, uh, so I could not share. But when we do our labs, there I believe there is the usage of sign function available in the labs. The grade greater than 80 and greater less than 80 could have been just grade less than 80. Grade. Mm. In that case, yeah, it could have been grade greater than 80 should be A. Yes, that could be one possibility. Yes, then we can remove and we can do this. Yes, it can never be greater than 100. But what I was trying to explain is that because we are missing equal sign here, if it is 100, then this would not work in that case. Okay, so the next concept is nested if statements or if structures. So nested if statements or nested conditional structures are those where if a statement, one statement, if a statement is in within another if statement. Okay. So here is one example. You see x equals 14. If x equals 14, and if x is less than 15, print x is smaller than 15. If x is less than 12, though it is not very good example, it is just showing because once we have precisely equal to 14, this is never going to be executed. This is the dead code in that case. But this shows that how you add one if statement within any other if statement. Okay. Or if this is the case, this code is here, you say that x is less than 4, if x is less than 10, x is smaller than 10, and you print that. And if it is not equal to 0, then you the remainder is not equal to 0, then you say that x is smaller than 10 and odd number. Here in this case, it is smaller than 10, but it is even number. So this could be one example here for the nested if statements. Now I have a question that when one if statement is within any other if statement, if there are two if statements nested, one inside another, what is that operation? Anyone?
Is it an and or?
It is precisely AND operation because you want to be true on the first if statement, and you want to be true in the outer if statement and inner if statement. Then when they both are true, only then the inner code is going to be executed. So if you want to write an AND operation without using the AND operator, then you can use AND operator. I'm not saying that you should do that, but this is an academic discussion. What I'm saying is that actually, when you are inserting or placing nested if statements, you are basically doing the AND operation. And when you are placing two or more if statements side to side, like so, in that case, this is OR operation. Okay, a kind of OR operation, not OR operation, but for the OR operation, uh, because they are not for the OR operation, that it needs to be for precise OR operation. In other words, that either of the conditions could be true. But here we see that only in this case specifically, one of the all if conditions is going to be true. But still it imitates the OR operation. But of course, nested if is always an AND operation. Okay. So far, any questions regarding if or nested if or anything else? Because we haven't covered yet, that's why not using it.
So nested is always a AND operation?
Nested if is an AND operation, yes.
Okay, thank you.
Now, alternate or alternative execution if else. That's why we were not using, now we will start using that. So basic structure is that we have if condition, okay, and we say that statement one or block of statement one would be executed if the condition is true. Else, if the condition fails, no matter what, the condition fails, then we have another statement or block of statements are is available for us to be executed. So in the flow chart, we can see that the flow is coming here. If yes, we go this way. If no, we go that way. Statement one is executed when the condition is true, and when the condition is not true, statement two is executed. And then after that, the program executes in the same order or in the same flow. Okay, now let's see some examples so that we can better understand. So here we have num equals 0, and we say that if num is greater than 0, print num is greater than 0, else print num is less than or equal to 0. Okay, and in that case, because num is 0 already, our else part of the statement would be executed. Okay, and here is another code for odd and even numbers, and we initialize number as 7, and then we evaluate whether the number is even. Okay, of course we know that if some number is not even, the only other possibility is that it is odd. So we here choose else, that the number is odd. No other option. If the number is even, if the condition is met for even, this is even. If no, then it is else condition, print odd simply. And remember that we have, for the else condition, we need to use the double colon or full colon, and also the proper indentation with the else commands that you need to run as a part or body of your else uh, condition or else.
And no,
command.
what would happen if you didn't indent that print? What would happen if you didn't indent it?
Then it'll be printing as a part of rest of your program.
Okay.
Now let's ask everyone that if we remove this indentation and rest of the program is same, what happens?
It will print odd in all cases.
All cases, even if it is if I make this number 8 and remove this, then what happens? Remove the indentation and make the number 8. So it'll be printing the number is even and the number is odd. Yes. Okay. Yeah, there is one more good point. Who is this? Sorry, I cannot read the name. Error. Of course, because you give the else statement and you do not put anything. Okay, we will cover this as well. Then there will be an error as well, because after else you need to give something. If you have mentioned else, you need to give some statement. Okay, even if you want to keep it empty. So we will see. Right, that is correct answer. That it'll be an error if we just remove this indentation, because else, if the keyword else is present in the statement or in the program, then definitely it requires some statement. Okay, now a few more codes here regarding if and else. I hope that you will be able to cover these by yourself, so nothing very complicated. Nested and multiple if else statements, though this is something we should cover. So here we have a program. So we say that enter the coursework, and that is in input exam, and that is an integer. Exam is score assignment. Okay, if the course is SMDS or the course is AI, and now there is an empty a nested if statement. So if you meet these conditions, either of these conditions, whether you are enrolled in AI or SMDS, then you go inside this if statement, and if your exam is greater than 50, you passed the exam. And when you pass the exam and your assessment is greater than assignment is greater than 20, you passed the subject. So you need to pass the exam as well as you need to pass the assessment to pass the subject. Okay, because this is now doing the AND operation. Else, if you have passed the exam but you haven't got more than 20 marks in assessment, you passed the exam but you failed the assignment. Okay, and it does not say anything about the subject, whether you passed it or not, but you passed the exam but you failed the assignment. Else, it means that if your total is not the exam is not is not 50, okay, then you print you did not pass the exam, because in that case exam might be a hurdle in this case. Okay, and by the way, we do not have any hurdle in our subject, so it should be a good news for us. And else, this is the else is this else is for this if command, and that is where we said that this, because if we are not either enrolled in SMDS or AI, we said that this course is whatever course you enter apart from AI or SMDS, it says that this course is not supported. So the main point here to consider is that for every statement, if there is else statement, we should match the indentation, and we should keep the if else structure in the same indentation level. So this else matches with this else matches with this if, and this else matches with this if. So the innermost one is with the assignment. For the assignment, the other one, the second innermost is for the exam, and the last one, the outermost, is for the subject itself. Okay, and any questions at this stage? Yeah, we've done this format would be just putting this, replacing this this curly brackets with the course you enter here. So that'll be just formatted. I would suggest you to just type and try using this. So if I say that I am enrolled in cybersecurity, And if cybersecurity is not masters of cybersecurity, and cybersecurity is not here, and it is not AI, it does not compare, so it will be printing the course cybersecurity. These curly brackets would be replaced with, because of this this format, this will be replaced with cybersecurity is not supported. And why we have done so? Because we wanted to have constructed a string that we were not sure about in the beginning. When we were writing the program, we were not sure about what user values are going to be placed here.
I know, just on that point, where the cybersecurity input come from? I can't say it.
Course here.
Of course, yeah.
Yes.
Yeah. The input, yeah, enter the core. Yeah, okay.
Okay. All good?
Yeah.
All right. Now change conditional conditionals. If, elif. Okay. So far we have seen if structures, and if condition is true, then statement one or certain conditions are executed, but not and then if it is not true, the else part is executed. But there could be certain conditions where we want to check multiple conditions as part of our conditional structure. We just do not want to rely only on one condition, that if it is true, then do this. We can have multiple conditions and multiple block codes associated with multiple conditions. Okay, in that case, we have if elif structure, and if passes, or if it is true, then rest of the code is not executed. Okay, if elif condition 2 is executed or is true, then rest of the code is not executed. This is one I would say the feature of elif structure. Okay, so now in that case, now you see that we have got a small program. We have got input income as float, and we say that if income is greater than $100,000, the text bracket is 40%. Okay, and the income, total income, or the net income we calculate here is income minus tax. Okay, the income is reduced by the value of tax. It means that 40% is reduced. Excuse me. If if it means that that was not the case, the income was not greater than $100,000, and if the income was greater than $50,000, so the income tax bracket is now 30% in that case. All right. We do not have any other conditions. Else is not present. So we are only having these two. So based on the value, so either of these two values would be executed. If this is executed, the program would not go and check for $50,000 bracket.
So no, what would happen if someone had 20,000? Would it just, the program would just stop?
It would just stop, yes.
Okay.
So if we want to add more brackets, so that we want to add more elif statements in that. Okay.
Is it just a matter of having less if and else to have the elif, or there is another purpose to that as well?
The main purpose is that we want to check multiple if statements, multiple separate if statements, and multiple if statement. That is one reason, and another reason is that we just want to make our execution or program faster, because if in the sequence any of the condition becomes true, the rest of the program or rest of the elif conditions, if they are in the same chain structure, in the same chain structure, they would not be executed, because it would be just picking the right if condition. Even if there are more right conditions in the if elif structures, they would be ignored in that case.
Thank you.
Yeah. Okay, so here another example. If num is greater than 0 is a positive number. If num is equal, it prints 0. And if num is less than 0, print negative numbers. So only one of these is executed, okay, based on the number. So we have got 5.6. In that case, it just prints a positive number, and it checks with the second condition and with the third condition as well. But if we keep the same program logic, but we change the structure into Aleph, now what happens is that in that case the same value num equal 5.6, it just checks with the num greater than 0, it prints positive number, and it just skips the rest of the code, so it won't be executing. So for this code it's okay, but when the code is huge, or there are larger number of statements, then of course this becomes, and they are inside multiple looping statements, then of course that becomes that gives us uh, a benefit in execution time, right?
So in this example, it's better to use Aleph rather than using if.
Pardon, can you please repeat that? What?
So in this example, it's better to use Aleph rather than using only if.
Yes, because we want only one out of these conditions to be executed at one time. We believe that if they are all exclusive, if any of these is true, the rest of these cannot be true, right?
Yes.
Yeah. So why checking this and this in that case?
Okay.
What link was exactly correct link? Okay,
Not sure if you can hear me. I accidentally clicked on the wrong thing and I was in the wrong area.
all right. Like you're talking about the Zoom link?
Yeah, correct.
All right. No worries. Okay, so indentation is, we have discussed it, but again, the convention is 4 spaces, but 2 are also acceptable. Even 1 is fine, but it is important if you do not provide indentation, it can cause error or not clarity if proper indentation is not maintained. Okay, in the chain conditional, they can introduce the possibility of having many different branches in the same selection controller structure. Only one of these branches will be executed, that we have covered, I think, and that is executed, that appears first. So now this is more relevant example. Which print statement will never be executed regardless of the input value? Yes, what do we say? Yes, LFX50. Huge, because any value which is greater than 50 is of course greater than 25, right? So the program would never execute, because always it will be big value. It will never be executed. Okay. But if it is 10, so it'll be comparing with this, and it'll not be true for this, will not be true for this, it will be true for 10, would be true for this x. 10 is greater than 5, so medium will be fine, small would be fine, but the huge is not going to be executed ever. Okay, some pitfalls. So increase indentation after if else statements. Maintain the indentation for all statements grouped under if elif or L statements, and reduce indentation to end the if elif or else block. Of course, if we want, that's what we have seen, how different if and elif structures were tied together. Okay. And blank lines and comment only lines ignore indentation rules, so they would not be considered.
What is meant by increase indentation?
It means that you want to start writing after leaving few spaces.
Oh, okay.
Yeah.
Yep.
Yeah. Like this is increase indentation. Okay. And we want to pair with this elif. So that's why we are not writing elif in the same print indentation orientation or column. We go back here, removing the indentation here. Okay, we increased indentation here, we removed indentation here. So this is what has been explained.
What is reduced?
That is reduced. If we started writing here, then we wanted to add another elif, so we reduced the indentation. If we would have added elif here, that would have been an error or not the right logic. So this, we are increasing, and here we are coming back from this structure or this indentation level to back to the original one. This is more visible here. Let me show you this example, right? Here, if we increase the indentation, okay, and then furthermore, we increase the indentation, we wrote the commands and if and else, and here we have reduced indentation because we wanted to match this else with this if. So we have reduced indentation and we have further reduced indentation in that case.
Got it. Thank you.
Some incorrect indentation. So yeah, so here you see that this is incorrect indentation. So this program would not be, yes, that's what I wanted to show you, that even if we want to leave some conditional structures empty and we do not want to execute any statements, then what do? We write a pass statement. So that your program does not break. So it knows that we don't have to do anything, we just pass. And for else statement, we have one statement. Okay. Some more examples or missing variables. So we also need to be careful when we are specifying or initializing any variables within the if statements. So sometimes they could cause error. So because x is equal to 5 and we say x is greater than 10, because this condition is not going to be executed and we want to print x plus y. In that case, because y was never initialized, this is going to be an error. So we want to, we need to take into account, or we need to take care of this as well. Okay. So the fixes are here. So x and y, you say x is greater than 10, then you want to modify y, but at least y exists. Okay, so then you write the program this way, or the other option is that you say that x has been initialized, but you want to say if x is greater than 10, then you want to say y is 42, else y is there, but it is 0. In any case, you want to initialize y to remove the chances of the error, because you do not want to miss the.
So when you use the word initialize, that represents that you're creating a variable and
Yes.
storing the value.
Yes.
Okay.
Okay, so nested conditional complex decisions can be handled. So let's see some examples. A negative positive, if the number is positive, also print out whether the number is even or odd. So I believe that we have seen a similar program. So here we have input. If less than 0, it is negative, but in the case of positive, we wanted to print nested. This is just a simple example. So, okay. Yes, sometimes having a lot of chained and nested conditional can get confusing. And using a print statement is a good way of tracing control flow. Does it mean that so you have a program, so you start printing here, you say that you print 1 here, print 2, print 3, print 4. So that way you now know that this is just one way of debugging your program. So you now know that what part of the program are executing. So this is one way you can do that. Okay. So whether it is 50,000 band or and by the way, what is uh, is this program correct or not correct?
Not correct.
Why not correct?
Because we don't have else statement.
It's not necessary that we should have. In my opinion, it is not correct because every time it sees this statement greater than 50,000, even 70,000, 110,000, they are all greater than 50,000. So the text band applied would be 30%. So that text band would never be applied. So that's why it is not correct. So now if we change the sequence, we say that the 100,000 is on the top and then second is the 50,000, that fixes the issue. Okay. So we can fix the problem by reordering the branches. So you see that when we say 100,000 is on the top, you have the text bracket of 40%, else if or elif, then you go for 30%. All right. Okay, that was all about the controller structures. And what time is it now? Oh my God. Okay, so
Now
we
you
can
know
take
how.
a quick 5 minutes break because still we have, I believe that 60 more slides, so 2 more main topics to go. We can take a 5 minutes break and we come back in 5 minutes.
Quick question: did the Google link from last week get fixed from the lab?
Yeah, that was fixed. Yes.
Ah, cool.
Yeah.
Okay, 5-minute break, yeah?
Yeah, 5 minutes break. Okay, so we are back. Now for the iteration topics, there are two different types of iterations which we will be covering. So iteration one, we'll be mainly looking at while loops and different kinds of while loops and nested looping or nested while loops and how to finish early in the while loops. Okay, so while loops. Now, before going into the details of while loops, we need to understand what are the loops. So sometimes we, in our codes, we want to perform, if we want to write some statements more than once or multiple times. Sometimes with the same configuration or the same actions, and more often with every run or every iteration, we want to change the execution slightly. But uh, we want to run the code, the same code, maybe a single line or maybe multiple lines, multiple times. So there comes the need for loops. So that situation is called looping or loops. Okay, while is one of those loops. So here is one example here. If, for instance, we say that we want to print from 1 to 5, either we type it we type the whole commands 1 to 5. What if we wanted to print on our screen 1 to 500 or 1 to 5,000? So every time we'd be writing these commands ourselves, but that is not we want. So we want some automation, or we want our Python program to do this for us. So there is like when we use the concept of iteration or looping. So in the flowchart, we say that there is a condition. Until the condition becomes true, we keep executing the command, that command or set of commands. And once that condition becomes false, we go and we do not execute these associated commands with the loop, and we go afterwards in the flow. Okay. So we use the while loop. While is pretty much similar to our if structure. In the if, the only difference is that it also evaluates a condition, and even the writing structure is same as our if condition. We have the keyword while in place of if, and we have the same condition or conditions evaluated and full colon, and the same indentation rules applied for our statements. The only thing is that the only difference, I would say, is that the if condition executes once. If it is true, it executes once. But while loop keeps executing all the statements within the loop body until the condition remains true. All right. So this is the difference. So here is the structure of while loop in terms of flowchart. It looks like this. Now, here is a small code. We say that I has been initialized as 1, and our condition says that if I is less than or equal to 4, and then print. And then after the print, we say that increment the I with 1. Okay. So you see that it keep printing because it prints because it enters into the loop body because I is less than 4. And then it keep incrementing 1, 2, 3, 4. And once it reaches 5, the value of 5, I reaches 5, and it goes for the comparison for one more time or one last time, and this condition becomes false. So it does not enter into the loop body, and print done is printed, because now, sorry for this capital P, because it should be small p. And then once the loop is completed or the condition becomes false, it leaves all the indentations or all this the while loop body, and it goes after that. It executes the statement after that.
And
Okay.
no, why should print be a small p, not a capital P? It's not an integer. Sorry, it's not a.
It's a keyword because it's a function name.
Okay.
Yeah.
Yeah, just a question. Now, this is beside the while loop. Can we use plus equals 1? Yeah, are we allowed?
You can use any statements, anything. You can even keep decrementing the value. It will still be working, but the loop would not be stopping. So it doesn't matter. So
Yeah.
there is
So
no
the plus equal is allowed, no?
plus equal is allowed. Yes.
Allowed. Okay.
Yeah. Plus 2 is allowed. Plus 10 is allowed. Whatever statements you want to run in that. Yeah. But this way we can do now 1 to 10,000. If we want to print 1 to 10,000, all numbers, all integers, we can do this without writing the command multiple times or 10,000 times. Okay. So this is our basic initializing, test, action, and then each loop, and then after that we print done. Okay. So how many times will the program print output x, and x is greater than 0 and greater than equal to 0. And here you see we are decrementing x. Okay, so it'll be printing 5 and 4, 3, 2, 1, including 0. Okay, but as soon as it becomes less than 0, the condition becomes false, and it just quits the loop and moves away or execute, because there are no other commands after the loop body, so program is ended. Now, types of while loops. So definite while loops. A definite loop repeats a fixed number of times. The number of repetition is known. All right. So in this case, we knew that how many times our loop is going to be executed. So this is fixed or definite loop or while loop. Okay. So here is improved times table example. We'll see in example somewhere. And indefinite loop repeats for a number of time which is not obvious before starting of the loop. So the condition that would be stopping the loop basically occurs inside the loop body. Okay, so that is indefinite loop. Now, indefinite loop could be based on user input. Interactive loop, we call it interactive loop. The user enters some figure or some number or some based on the user interaction, the loop finishes or loop continues. And it could be finished based on the computed values. Okay, the loop body or the loop condition does not decide that, but inside the loop body, some computations are made, and that those computations then are used in the condition evaluation of the loop. Or sometimes we say that we never want to finish a loop, so the condition would always be true, and it would be doing the operation for all the time. Okay. So an interactive loop has a condition which decides when to finish repeating based on user input. So let's see here. We have got if item here we have a program which calculates the total cost of the shopping, for instance. So item cost, you start with a float value, and if it is already 0 or negative, negative number, not 0, then it would not enter into the loop. And then it adds to the total cost. The cost you enter here, if it was not negative, even if it was zero, it would come here and it would enter. But as soon as you enter the item cost that is negative, the loop will finish. Okay. And the total cost would be printed. Okay. Now, there is a question, will a while loop be triggered if another part of the program is running, that is known serial program execution? In a sequential program, it would be when the condition becomes true. But if we are taking the example of threads and other complicated or complex, I would say, concepts, then it could be a different story. But even then, in the threads, everything is the program basically maintains the sequence. Okay, so a loop can have condition which is based on a complex computation made by the loop. Let's see if we have some example. We don't have any example, but we understand the concept that if certain values are computed, and they can then trigger the loop to finish. And sometimes we never want to finish loops. They would be there forever. It's not always the program would be crashes. Sometimes they can crash, but sometimes we keep our loops running on purpose. For instance, in a routing device where packets are being routed to particular networks, so we keep receiving our packets from one network, and we keep routing those networks, and we want to keep doing them always. Or for instance, there could be a program in your car that is measuring certain driving conditions, and we do not want it to, and they can take certain actions based on different driving conditions, and we want to sample those driving condition say multiple times per second. So in that case, we want our infinite loop to be executed. No, it's not the requirement that we always assign zero value. You can assign any value. So a variable is a variable, you can assign any value. So how many times will the Python script print output in that case? Infinite time, because x times 2 is what? Is 2. And because this statement is outside the loop body, right? So it'll be printing x, and that is what? 1. It'll keep printing 1 forever. Nested loops and finishing early, like if statements, we can nest loops. Okay, so here we have one example. We have got while a is less than 12, less than and equal to 12, and we've been initialize, and this is the particular example. If we are not initializing a variable with 0, we are initializing with 1. Okay, and we have got another loop within the body, and remember that the nested loop should have proper indentation followed. Okay, this was the program for the times table. Okay, and here we are printing tables of from 1 to 12. For each table, it will be printing 1 to 12. So if you execute that, it'll be printing tables. Okay, finishing the current iteration or entire loop. Sometimes we want to finish our current loop execution, but we just do not want to quit the loop. Then we use continuous statement. Otherwise, if we want to quit the loop body forever, depending on the conditions, then we use break statement, right? So let's see some examples here. We have x equals 0, and we say that x condition is that x is less than 10 if x is we want to find that if whether x is an odd number or even number. If x is an odd number, then you say that x equals x plus 1 and continue. Okay, and after that you print. Okay, what is happening here? Every time, because x, the increment is by 1 in the value x, assumes all the values from 0, 1, 2, 3, 4, 5. But what if condition is doing some action, and that is doing what? It is incrementing the value by 1 every time, and it continues. When the continue statement is found in the loop body, the further statement within the loop body are just ignored, and it goes back to the check condition. It checks again. Okay. And that's why you see every time it finds an odd number, it does not allow print statement to be executed. But if it is odd this does not this if condition does not become true, hence it continues and it prints. Okay, and that x plus 1 is executed here rather than here. Okay. And finishing the loop early. So if we want to completely quit the loop, we can use the break statement, and break statement can be used to finish the loop early. What exactly you want to explain me? You're welcome, but can you please mention that what?
The previous one with the continue. Yeah, this one.
This one?
Yeah.
All right. So let's have a look at this carefully. So x is 0. It's fine. And when we come to the while loop evaluation, the condition evaluation, what happens is x is less than 10. Okay. And the loop executes. It enters into the body. Now the second condition of if is evaluated. For 0, that is not true. Okay, this condition is the loop. Inside the loop, the program flow does not enter into these conditions. It does not run these two conditions, these two statements, sorry, but it prints 0 as is, and then it increments the value of x. Now, this time value of x becomes 1, and it goes for the second round and it evaluates. Now x is less than 10 again because it is still 1, but now this time it is an odd number. This condition becomes true. Okay, as soon as this becomes true, now it enters into the body of this if statement and it increments the value by 1. Now x becomes 2 in this case. All right. And the next statement after incrementing the value is executed is continuous statement. And continuous statement brings the control back to the while loop. Okay, it does not allow the flow to go to print or x equal x plus 1. It brings the flow back to the evaluation of the while loop. Now this time it is 2. And when it is 2, it enters again into the loop body, but because of this statement not being true for the value of x equal 2, it is not executed. If statement and if statements related to the if block is not executed, and it goes and prints 2. and it does not print 3 in the same way. It prints 4, it does not print 5, it prints 6, ignores 7, prints 8, ignores 9, and of course when it becomes 10, still it is an even number, but then while loop ends because the condition becomes false. All right.
Thank you.
So, excuse me, Dr.
No,
Moore.
no, yeah, please.
If we remove the x equals x plus 1 on before the continue, then it will goes to infinite loop. Would it be?
Let's see. Because when it is 0, yes, it can go. Yeah, it'll be going to, because it will be always 0, and even let me check. It'll print 0 first time, and then it becomes, definitely print 0, and then when it is 1, it would go to yeah. After printing 0, it should not have any increments, and it would stuck. It would be stuck. Yes, it'll just print 0, and then it'll keep continuing with the value of x equal to 1. Yeah.
And no print. Okay. Yeah.
Only
Got-
0 would be printed, and nothing else would be printed. And the program would keep running.
Yeah.
Yeah.
Got it. Thank you.
Break terminates the closest loop and executes the first statement after the loop. Yes, the break statement breaks the loop in which it occurs, basically. Yes.
Is there a way to reference how many times a loop has run before meeting its condition?
It'll keep running until the condition is true. As long as the condition is true, it'll be running.
Is there a way to reference that? So could I be like if I wanted to print the number of times the loop ran. So in this case, I wanted it to print the number 5 because this loop ran 5 times.
Yeah. So what you can do is just after that, after the while loop, as soon as it enters into the body, you can print some variable, not x in that case. Okay, you can initialize another variable outside the loop, and you say that is y equals 1, and you print y. Okay, and then you say y equals y plus 1. All right.
Okay, thank you.
Yeah, so every time the loop runs, so you know that y is being incremented as well as printed. Sorry, because we are a bit late. We are about to finish. We have a few more slides, but if you have some other commitments, you can leave because the recording would be available. But I'd be happy if you continue. Okay, so and this is the largest of all the contents in terms of module, and we need to cover this. Okay, we have covered the almost this. Okay, so total cost calculator. Here we have total cost equal 0, and while true, here we have done what? Rather than based on the value itself or item cost, we said that while true. Now this loop is not going to be terminated because we have fixed coded it to be true for all times. But of course, we want some mechanism to terminate the loop and to show us the total cost. So what do we do in that case? We keep inputting the cost, and we say that if the item cost, someone enters a negative cost, that is an indication that they do not want to continue with the shopping, or they do not want to enter further items. So it breaks the loop, okay? And the total cost is printed. Yeah, you can use it, yes. Of course. Okay, now logically, do you think that this program is good?
No,
And why not?
it might get into an infinite loop. Your logic is not right. If your logic is right, it's all right. But there's a risk of getting into infinite loop.
No, why? If I enter -10 after entering 10 values, if I
right,
enter
but-
-10, it is not going to be infinite.
Okay,
loop.
yeah, that's true. But
So
this-
still, after my point is that
Yeah.
because there is a break statement, it won't be adding that final cost to the item.
Yeah.
Okay. But
The
is it
zero
okay
answer
or is
will
it
bring
not
it.
okay?
And then the less than 0 to break.
It is not, it is okay because we know that the final cost which we want to add is already a negative value and which we of course do not want to add. That's why this total cost is after the break or if statement. If it was earlier than this if statement, then it could have caused the error, logical error. Okay. Did you get my point? What I tried to explain, that this total cost would not add the item value which is negative. For instance, we bought certain items that cost $100 and then we entered -10 to terminate the loop. The total cost would not become $90 because break would happen before this. So here is a summary of while loop now. Iteration 2 for loops. I have removed this program FizzBuzz from the because it was not the, but I'll keep this in the PPT. But that was taking quite a few, I'd say, PPTs or slides. Okay, for loop now, pretty much same as our while loop, but here that is not depending. The for loop, the execution of for loop does not depend on a certain condition. Rather, it runs based on a variable in a sequence or value of a variable. Okay, so we can say they are kind of fixed loops as well. So if the sequence is present, okay, the loop would be continuing. So we have a sequence of numbers, data items. Each value of from a sequence is picked, processed, and once the sequence is finished, then the loop is finished. Here is a difference. A while loop, we can see it prints 1 to 10. For loop in the same configuration, we say I in range 10. Now, range 10 means that it'll be having values from 0 to 9. Range does not include the last value. When we say 10, it starts from 0 to 9. Okay. So, of course, many common things are there. Continue and break statements are there. You can nest them. Okay. And indentations are followed as well. Okay, and of course the same full colon and indentation for the structure is required. Now let's have look at some explore some range function first. So range is a function that creates values, multiple values. When we pass single positive variable, not variable, sorry, a parameter to it. So we say that if 10 is passed, so it will be generating 0 to 9. And when 1 comma 10 is passed, it will be generating 1 to 9. 10 is not included. When we say 3 to 7, the values 3, 4, 5, 6 are generated. When we say 2 comma 15 comma 3, so 2, it starts with 2 and it goes up to 15 with the increment of 3. Okay, because 15 is as I said, that 15 would not be the last value, would not be included, so that is not included. Even if it was to include, because 14 plus 3 is 17, that is greater than the top range, so it would not be included. So if we want to have some decrement, some sequence generated in the decrement or decreasing order, so we can start with, say, the larger number first and the smaller number later, and the negative decrement. So we start with 9 and we say go up to 2, and it'll be going 9, 8, 7, and excluding the larger number, or the second parameter, not the larger number, sorry, excluding the second number. So it goes from 9 to 3. Valid ranges sequence. So 1, 2, 3, 4, that is valid. We can start from 8 to 10. We can have 6, 3, 0, -3. We can have just fixed value 100. So invalid ranges 1, 4, 9, 16, 25, because they are squares. Floating point ranges, they are not possible, and we cannot have same number repeated in a range. Okay.
So you know, why can't you use squared numbers in the range?
Because it generates in a linear fashion. How do you define then the increment in case of, what do you input to generate squares? Though you can use loops and other techniques, but the range function itself, how do you specify this for generating squares? Do you understand that it is a linear linear function?
Can I just, the second example, you couldn't make the range start at 1.1 and end at 4.1 and make the step 1?
We'll have to try. I think that I'll have to check. I don't think so that it works.
Okay.
We can check. Maybe we can check in lab session that it. But I have, I believe that it does not work this way.
Okay.
Yeah, I'm not sure that's also right. I'm not sure that. So the basic step, the basic format is that we follow M, N, and step. We start from M, stop at N, excluding N, and then steps are taken. Well, I think that enough of range net moving forward. Some more examples. Check your understanding for I in, fill in the blanks using a Python range such that the program output is 9876. So you want to start from 9 and you want to end at 5, and -1 is your decrement. Okay. Now for loops, here are for loop examples. Okay. So you want to print all the numbers in range 4. So it would be printing 0 to 3. And for letters in CSE IP, it would be taking letter, would be assuming one letter at a time. Okay, so current letter is CSE4IP. Okay, and in the case of letters, in case of this including not the last number, is the function of the range, not the loop. So P here would be included. You understand that what point I am trying to make? So not excluding the number, the last number in the range is the function of the range, not the loop. So sometimes we can get confused with this. So in that case, a letter from CSE4 IP, each of these letters would be picked at one time. Okay, and that would be substituted here in place of these curly brackets and will be printed. Okay, write a Python program to find all the number which are divisible by 5, but not multiple of 3 between 10 and 50. So how do we do that? So we have range 10 and 50. Okay, and if I is divisible by 5, that means the remainder is 0, and here the remainder is not 0 in case of 3, then you want to print I. So 10 is divisible by 10 is divisible by 5, but not 3. 20, 25, because 15 could be divisible by 5, but also by 3. So we have not included here 15. So these are all the numbers which meets our criteria. Squared integers from 1 to 10. So in case we want to generate squares, so what we want to do, so we have a range in 1 to 10. Okay, and if I equals 1 and either digit 1 or 9, so that is one condition that that the square that either ends with digit 1 or 9. Okay, and how do you find that? You divide that squared number with 10, and the remainder, either it should be 1 or the number should be 9. Because if it is, say, for example, it is 99, and you divide 99 by 10, the quotient is 9, but the remainder is also 9 in that case, and 99 is meeting that criteria. Okay, so let's see what is printed in that case. 1 is printed, 49 should be printed. Do we have 4 should not be printed? Then 1, 4, 9 should not. 9 should be printed. Yes, 9 should be printed. A square of 3, and 49 and 81. Yes, this is the range, right? Now, for loop break works the same way. It just quits the loop. All right. So if I equals 3, it quits. So 0, 1, 2. The range would have gone up to 4, but it quits at 3. Here in this example, if we say the letter is I, it quits. Okay, after printing the I letter, it quits. So CSEI, P is not printed. And continue is works the same way. It does what? It continues with the next variable value from the loop condition, or the loop or from the looping. If it is range, or if it is letters, or whatever it is processing, it'll continue as soon as it sees continuous statement in the loop body, it goes and picks the next statement from the loop. So in that case, you see, if it is 2, it is not printing 2, rather it goes and it fetches 3 and 4 in that case. All right. Check your understanding. Does the order of elif branch matter for getting the correct output? I think this was coming from the FizzBuzz. I'll keep the FizzBuzz program here for you so that you understand what is that? It's just a simple program. Now, aggregation is one more important topic. Aggregation is when we want to combine values or process values based on the single values from the looping around. So this includes summing of values, average or maximum or minimum values. Okay. So aggregation sum. For instance, we want to find the sum of all the values in range 1 to 10. All right. Excluding the 10. So from 1 to 9. So we can write this code. So the total sum would be printed in that case. And we want to average the mean value from 1 to 9. So we have total number and total count. We want to divide the total with the count. So we would have x in range 1 to 10. Total would be the sum of all the x values, and we keep counting how many values are there. So 1 to 9, there should be 9 values, and then after the loop is finished, we calculate average by dividing total with the count value. Okay. And maximum or same goes with the minimum value. You can find maximum or minimum values, though we have functions available, but this is for the learning purposes, that what the aggregation is and how we can implement the aggregation. So we say that maximum is 0 at this point, and we want to find the maximum in the list. Okay, we do not want to go into the list. This is and we are not using the range here in deliberately, because we know that the last value in the range is maximum. So we just pick the list here. There's a list of random values. We are not concerned about the list because we haven't covered yet in the lecture. We will be covering in much more details about lists and dictionaries and other data structures. So X would be assuming all the values one by one in this list. So 3, 1, 8, and 4 at one time. So if the condition evaluates the if X is greater than maximum value, then the new maximum becomes X. Okay. So in that case, X, when it was 3, this becomes true. Now the maximum value is 3 because 3 is greater than 0. In case of 1, this condition does not become true. So it ignores this and loops around next time, and it fetches 8 next time. And then the next maximum becomes 8. But in case of 4, when it goes around the next time, this does not become true. So now maximum holds the maximum value from the given list. So it prints maximum value. And count is where we want to count the how many numbers are there in a list, or even in a text. For instance, if we wanted to count how many numbers are there in this in this text, so that can be treated as an aggregation problem. Okay, for X in these numbers, so yeah, so you want to count all the numbers, but here the question says that you need to count a program. In this program, you need to count all those numbers which are greater than 5. So it should be 8 and 9. Okay, so 8, 9, and 9, there are 3 numbers. So every time it counts, it finds a number from the list which is greater than 5, it counts. So it is 1, 2, and 3. 3 times it finally prints 3. There could be custom aggregations you want to do. So you want to, it really depends on your aggregation formulas. Okay. So write a program which concatenates all single digits number into one long string surrounded by the square brackets and prints the result. Okay, so you can write this program like so. So you first keep aggregating all the numbers in the string, you need to typecast X in the range 0 to 9. And once that S has been generated, then you concatenate further X with the opening and closing square brackets, and you print that. Okay. So which program correctly calculates the product of values between 1 and 10 inclusive? Yes. Anyone? Why not B and why not C?
Because the initial number is 0 in B.
Mm-hmm.
And product of 0 is 0.
Yes. And why not C? What is the problem with C?
The product variable.
Because X becomes the new product. Okay. Right. Here it should have been prod equals prod time X, not the X equals. So X is being changed because we do not want to X to change. We say that X is coming from our loop. All right. So nested if loops, we can use similar method. We can use loops within for loops, or while loops within for loops, or for loops within while loops. Everything is possible. So nested loop examples. Here you want to print the Pascal's triangle, and Pascal triangle is that it takes some value and it prints stars and the Pascal value. Okay, and it does all the right calculations. All right, and if it is 5, it should be printing 5 stories, 1, 2, 3, 4, 5, or 5 layers. Okay, and here you see that we use nested while loops in that case. Okay, so here is another example of printing stars. Okay, or printing just numbers 111, 222, and so on. Okay, all good. So this was all about the loops. We have covered comparisons and Booleans, logic, and conditional executions, and iterations in general, including while and for loop. Now, if you have any questions, you are welcome.
I have a question.
Yeah,
Can
sure.
can we submit the assumption more than once before the deadline?
No, only one submission is allowed. If you submit it, you cannot remove and edit that.
You can't, if you find a mistake, you can't correct it. No, you
No.
can't. Okay,
No.
okay.
Yeah.
Okay, that's fine. Thank you.
All right. Okay, all good. So if we do not have any particular questions regarding the lecture, I would be ending the lecture here so that our recording ends here, and I'll be switching on the other session where if you have any other questions, you can come and join.